Welcome to Brain Vision.
In this problem, on the topic of magnetic fields and magnetic forces, we are told that a straight vertical wire carries a given current downward in a region between the poles of a large superconducting electromagnet. We are given the magnetic field of the magnet, and we are asked to calculate the magnitude and direction of the magnetic force on a 1 centimeter section of the wire if the magnetic field is oriented in different ways. So firstly, if the magnetic field direction is east, now we'll use the equation F is equal to I times L times B sine phi, where I is the current, L is the length of the section of wire, and B is the magnetic field strength. So for part A, we know the current goes downward into the page, and the magnetic field is to the east. So using the right-hand rule, we get that the force applied on the wire is directed south. So phi here is equal to 90 degrees, the angle between the magnetic field and the force. So we can calculate the force using the equation above. F is equal to I, which is the current 1.2 amperes, times the length of the wire, which is 1 centimeter, or 1 times 10 to the minus 2 meters, which is 1 centimeter, times the magnetic field strength, which is 0.588 Tesla, times the sine of 90, which is 1. And so calculating, we get the force acting on the 1 centimeter section of wire to be 7.06 times 10 to the minus 3 newtons. Now, for part B, we are told that the magnetic field direction is south. So again, we'll draw a diagram. We have our current downwards into the page, and our magnetic field is oriented to the south. So again, with the right-hand rule, we find that the force now points to the west. So with the force being directed to the west, phi is again 90 degrees, the angle between the force and the magnetic field. And so again, F is equal to 1.2 amperes I times L, which again is 1 times 10 to the minus 2 meters, times the magnetic field strength, 0.588 Teslas. Sine of 90 is again 1. So this gives us the same answer as part A of 7.06 times 10 to the minus 3 newtons. Now, for the final part C, we are told that the magnetic field is oriented 30 degrees south of west. So if that's west, and the magnetic field is oriented at an angle of 30 degrees below west, we'll use the right-hand rule again, which tells us that the force applied on the section of wire, F, is oriented at an angle of 60 degrees north of west. So again, we have the angle between F and B to be 90 degrees. And so our force, again, I times L times sine of 90. So again, it's 1.2 amperes times the same length, 1 times 10 to the minus 2 times 10 to the minus 2 meters. And again, the magnetic field strength is 0.588 Teslas times the sine of 90, which is 1. So we get the same force as parts A and B, which is 7.06 times 10 to the minus 3 newtons. So we can see that in each case, the current direction is perpendicular to the magnetic field. And the magnitude of the magnetic force is the same in each case, but only its direction depends on the direction of the magnetic field.